Hello, 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 hello. Hello, good evening. Good evening, dear students. I hope I'm audible to all of you. Good evening, good evening. Hello, everyone. I hope my voice is clear to all of you. So, as you know, uh, we have started, DTC has started a Aim GPAT series. So, in this series, what we are going to do is we have planned a lecture, daily 2 lectures. Okay. So in that 2 lecture series, today I will take care of this subject biochemistry. Okay. I hope my voice is audible. Please confirm in the chat box. Please confirm me in the chat box. Okay. So, so first term is, so today we are going to talk about biochemistry. What biochemistry exactly? Biochemistry. So if you will break this word in two parts, one will be your bio, another one is your chemistry. When the word bio comes to the picture, and you guys already know bio means living, living. So we will talk about here living organism, organism. And chemistry, what are the play of chemicals in our body? So biochemistry, if I will define the biochemistry in a simple term, a simple sweet term, so this is the chemistry, this is the chemistry of biomolecules, chemistry of biomolecules in living organism. Okay. Now, here another word comes to the picture. So, what is that word? That word is biomolecule. So, biomolecules are any compound, so which, when present in our body, it basically carried out many type of functions. So including your cellular respiration, including your blood homeostasis, including your energy production, building block of your muscles, nerve impulse transmission, many functions of our body is regulated through these biomolecules. And these biomolecules, if I will name, so these are your carbohydrates. If you have any questions, so please put it in the chat box. I am here to answer your question. Carbohydrates, proteins, lipids, vitamins, minerals, enzymes. So these are basically nothing but, so these are the biomolecules, and these biomolecules plays a significant role in our physiological system. So in this biomolecule list, today we are focusing on this carbohydrate. Okay, carbohydrate, we call it as a carbs. Shortly, we call it as a carbs. So carbohydrate, what is? So carbohydrate, when we heard this about carbohydrate, we remember this sweet thing. Your sugar, your cakes, many things. So the things that taste sweet, that are nothing but they are basically carbohydrate. Okay. So carbohydrate, please remember, carbohydrate is the most abundant organic molecule. It is the most abundant organic molecule. So what is, organic word when come? organic word means it should consisting of your three molecules: hydrogen, oxygen, carbon. Hydrogen, oxygen, and carbon. So they are consisting of hydrogen, oxygen, and carbon. Three major things. And they are nothing but they are polyhydroxyaldehyde or ketone. That means they contains multiple group of functional group of this aldehyde group or this ketone group. They are consisting of this ketone group or this aldehyde group. That's why they are called as aldehyde. They are called as polyhydroxyaldehyde or polyhydroxy ketone. Okay. Now next thing is what? So what exactly this carbohydrate looks like? Why we read about carbohydrate? So now we heard that yes, carbohydrate is the most organic compound. It is made up of carbon, hydrogen, oxygen, and it is polyhydroxyaldehyde and ketone. Now my question is, so if I will ask or someone will ask why we should read about carbohydrate, because carbohydrate is the instant biomolecule which provide us energy. Without energy, we cannot survive for the walking, for talking, any internal function, any external function, for any type of activity. Energy is the must need thing. So for that energy, what we basically require? We basically require a thing that is carbohydrate. So carbohydrates are basically most abundant dietary source of energy. So 1 gram of, please remember, 1 gram of carbohydrate will give 4 calorie energy. Okay. 1 gram of carbohydrate will give 4 calorie of energy. This is a very, very important point. You should remember, question can be asked. Next, carbohydrate not only for the energy, it also acts as a precursor for many other biomolecules like your fat and amino acid. I will I will explain in our upcoming classes. We will explain that how this carbohydrate is related to this fat and amino acids. Next important thing is, yes, very good, 4 kilocalorie enzyme. Okay. Next, carbohydrate as a glycoprotein participate in the cell membrane structure of cell membrane, cellular functions such as growth, adhesion, and fertilization process. Okay. Next is carbohydrate are the structural component of many organisms, which includes fibers like cellulose in plant, exoskeleton of some of the insect, and cell wall of many organisms. Carbohydrate also source as a storage form of energy as a glycogen when we meet the immediate energy demand of the body. There are, you might heard about this fasting condition. When we fast, Acha, can you tell? So where we get the energy during fasting condition? If a person is someone is in a fasting condition, so where that person will get energy? Yes, answer me in the chat box. Where that person is getting that energy? Please remember, fat or amino acid, fat or fatty acid. So fatty acids, so these are basically stored in our body, and when we are in a starving condition, so there is a condition called gluconeogenesis. What is that name? Gluconeogenesis. Okay. So we will discuss about that. Yes, very good. Fat. So this process of gluconeogenesis, so carbohydrate will be synthesized from non-carbohydrate sources. And when it will uh, it will activated the person will go for fasting condition. Now, we have understood what is carbohydrate, what is storage from glycogen. Very good. Very good. Please answer in the chat box. I want to, I will see all of your answer. Okay. So whenever you feel any doubt, you directly put this message in the chat box. I will answer it. Okay. Next, types. So when we heard the word types, so there is a three major type of carbohydrates. One is your monosaccharides, oligosaccharides, and polysaccharides. Oligosaccharides again of two subtype. One is called disaccharides, another is called, yes, yes, trisaccharides. Next is polysaccharides. Yes, polysaccharide is how many types? Polysaccharide is two type. One is your homopolysaccharides. Yes, dear students, answer it. Another one is heteropolysaccharides. Okay. One is homopolysaccharide. Another one is your heteropolysaccharide. Next, important thing is talk about monosaccharide. So mono means single. Okay. So when we heard this mono word, mono means single unit. So these are the simplest sugar. We can call it as these are simplest sugar. So it has a basic formula to for this monosaccharide. So there is a general formula. General formula. That formula is CnH2nOn. CnH2n. Yes, mono cannot be hydrolyzed because it is the simplest form. Okay, very good. Mono cannot be hydrolyzed because it is the simplest form. Okay, so there is a general formula that is CnH2nOn. This is the general formula. Please remember, many times this question asked, and I will show you what type of question asked in exam. So see, that means one molecule of 1 unit of carbon, 2 unit of hydrogen, and 1 unit of oxygen. Okay, so these are the simplest sugar. They are sweet in taste. They are having sweet taste. Okay, they are having sweet taste. Okay, now, so as we discussed, so they are either they have two type of functional group. This monosaccharides having two type of functional group. One is aldehyde. If aldehyde functional group is present, we call it as a aldose. Okay. If ketone functional group is present, we called it as a ketose. So please remember, if aldehyde functional group is present, we call it as a aldose. If ketone functional group is present, we call it as a ketose. Let's learn basic information about this. So monosaccharides or oligosaccharides, they are having sweet in taste, crystalline in structure, soluble in water. They are commonly called as sugars. Okay. Next important point, they are generally formula is CnH2ON or CnH2nOn. Okay, so they are cannot be hydrolyzed. Very good. So they cannot be hydrolyzed. Depending upon the functional group, they are either called as aldose, having aldehyde functional group, or they are ketose or ketone. Now, next is these monosaccharides are further classified into triose, tetrose, pentose, hexose, heptose. Now, question will be asked, what is the carbon number of simplest sugar? Question can be asked. So please remember, this is very important question. So triose, C3. Please remember, if the question will be asked, what is the carbon number of lowest carbon containing sugar? That is your triose. So again, triose is two type. As we discussed, this is one is your aldose, another one is your ketose. So let's discuss all the example one by one. Now let's talk about oligosaccharide. I will discuss all the example one by one. Let's discuss that first. Okay. So first is your monosaccharides. So monosaccharide example is your triose. So triose example is glyceraldehyde and dihydroxyic acetone. Glyceraldehyde is aldehyde functional group and dihydroxyacetone is ketone functional group. Very good PK solution. Very good. Correct answer. Tetrose, erythrose is aldehyde, ketose is erythrose. Next is similarly pentose example is ribose, ribulose, deoxyribose, xylose, xylulose. Again hexose is glucose, galactose, mannose and fructose. So please remember glucose is a C6H12O6. Glucose is a C6 carbon containing compound. Okay. Heptose example is D-pseudoheptulose. Again, oligosaccharide as we discussed, there are two types. One is your disaccharide, another one is your trisaccharide. Disaccharide example is your sucrose, lactose, maltose. Trisaccharide example is your raffinose and xanthine. Okay. Now, next, and the most important part, that is your polysaccharide. So polysaccharide always ask question from the example of polysaccharide. So polysaccharide either they are homopolysaccharide or they are heteropolysaccharide. Homopolysaccharide are those when they are consisting of single type of sugar unit, we call it as a homopolysaccharide. Hetero means different. When it's consisting of different type of sugar unit, we call it as a heteropolysaccharide. Okay. So this homopolysaccharide example is your starch, dextrin, inulin, glycogen, cellulose. Heteropolysaccharide example is your hyaluronic acid, chondroitin sulfate, heparin, keratan sulfate, dormatan sulfate. So now you might feel that yes, there is confusing how we will remember. So there is there any trick to remember? Yes, there is a trick. So first tell me, all of you are understood or not? If you understood, please put a thumbs up in the group. So I will understood that yes, you guys have understood the thing. Then I will share a very easy and important trick where you can remember all the your homopolysaccharide and heteropolysaccharide. If you understood, put a thumbs up in the chat box. I will explain you the trick. That trick is very important. You will never forget if you will remember that trick. Okay, very easy topic. Okay, that trick is how you are going to remember. So to remember homopolysaccharides, the trick is you should remember GDC is super. You know GDC is super for all the pharma competitive pharma aspirants. So G for glycogen, D for dextrin, C for cellulose, I for inulin, S for starch. GDC is super simple mnemonic. So to remember homopolysaccharide. Next is inulin. See, there you should remember the difference between inulin and insulin. Insulin is a hormone which secreted from the beta cell of pancreas. Inulin is a homopolysaccharide. What is its function? What is its function? What is the function of inulin? It is used to measure the glomerular filtration rate. It measures the GFR. What it measures? It measures the GFR. Understood? Now, to remember heteropolysaccharide, there is also mnemonic. How you can remember this heteropolysaccharide? So, heteropolysaccharide can be remembered by simple mnemonic. King calls his department head. Simple mnemonic is that inulin is used for the kidney function determination. Very good, very good. Correct. For the determination of GFR. So how to remember heteropolysaccharide? So this heteropolysaccharide is remembered by simple mnemonic. King call his department head. King you can remember as a keratan sulfate. Call from call you can remember chondroitin sulfate, hyaluronic acid, dermatan sulfate, and heparin. So these are the examples. So renin, the renin, it is a what? It is a component that released from kidney when there is a, so renin is what? It is a hormone you can call. It is a hormone or chemical. It released from it released from kidney. So when it will release, when there is a any type of problem in your blood, like if you have uh, your blood concentration is increased, when your blood pressure is decreased. So in that condition, so this in the renin is released and that activate one pathway that called as RAS, renin angiotensin aldosterone pathway, which we will discuss in our subsequent class. Okay. Now, as you know, so we have started a new batch for GPAT 2026 and 2027 in specially English language. Okay, especially in English language, where we are going to teach you all the subjects of you for your GPAT. Okay, so what you will get in that course, so you will get that course in 500 plus live classes, 23 hard copy books, 38 plus previous year question, 500 plus daily practice paper, 500 online test series. And for if you will take for 1 year, the price will be 14,000, and if you will take for 2 year, it will be 18,000. And if the batch will be start from 29th of June. So screen is not visible. No, my screen is visible. Please check your internet connection. I think that you might have internet issue. You can uh, rejoin once. Okay. So I think my screen is visible now. So let's talk about this different type of sugar and their function. So glyceraldehyde 3-phosphate, it is an intermediate in glycolysis. Dihydroxyacetone, it is also intermediate in glycolysis. Erythrose, it is act as a intermediate in different carbohydrate metabolism. D-ribose, it is for the structure of RNA, and you remember a D-ribose and deoxyribose. These are two sugar. It is present in the nucleic acid. Okay, and this question will be asked. So, what is the difference between D-ribose and deoxyribose? Okay, one question always asked. Let me tell you. So, the difference between ribose and deoxyribose is C2 position hydroxyl group. In case of deoxyribose, the C2 hydroxyl group is not there, but it is present in ribose. This question many times asked in exam. Please remember the carbon number position is C2. Okay. So whatever point I am discussing here with you is very, very important from exam point of view. Okay. So this point you should highlight. Next is xylose. It is an intermediate in HMP shunt. We will discuss it. Xylose, glucose. It is the major energy sources. Galactose, converted glucose, and its failure leads to galactosemia. D-mannose, it is the structure of polysaccharides. D-pseudoepilose, it is intermediate in HMP shunts. Sucrose, lactose, mannose. Sucrose is mostly commonly used table sugar for the supply. Lactose, it is the milk sugar. Maltose, it is the product of starch hydrolysis occurs in germinating seeds. Okay, now, so up to what we have discussed. So we have discussed here about what is carbohydrate, what is its functions, what is its structure, what is its classification, and these classic uses of this component. Okay, I hope it is clear to all of you. Next, chemistry. Very important part. Carbohydrate chemistry always asks from question. The chemistry of carbohydrate is a very important topic. Okay, it is important for your exam. Carbohydrate chemistry. So carbohydrate chemistry, let's start. So first point is stereoisomerism. So what is this stereoisomerism? So stereoisomerism is a property. So when the Structural formula is same, but the arrangement of the compound is different. You can see over here. Here, glucose. If we take an example of glucose, glucose having formula C6H12O6. Okay. Now, here there is a different type of arrangement we can form. So this is glucose and this is also glucose. But it is D-glucose and here it is L-glucose. And you know, D-glucose is also called as dextrose. It is more active than L-glucose. Question can be asked in exam. So what is the difference between D-glucose and L-glucose? So D-glucose is the dextro form of glucose and it is more biologically active as comparison to the L-glucose. So stereoisomerism, what you understood? If a person or if a compound which having a similar or same chemical formula, but there is a difference in the arrangement of the carbons. If there is any type of difference between arrangement of carbons, then we call it as a stereoisomer. It is important characteristics of monosaccharide. Now, so one of the important point about characteristics about this, just give me a second. One of the important characteristics point about this glucose is the stereoisomerism. Just give me a second. So one important point regarding this uh, glucose is the stereoisomer is asymmetric carbon. What is that? That is your asymmetric carbon. So in asymmetric carbon, when four different functional group, when four different functional group attached to a single carbon, it is called asymmetric carbon. Can you tell how many asymmetric carbon present in glucose? This is one question asked in GPAT previous year. So number of chiral center, number of chiral center. Tell me in glucose. What is the number of chiral center in glucose? Yes, L-glucose is not visible. Now I have arranged it. It is now visible. It is visible, na? Wait. See, this is the structure of L-glucose. Tell me how many chiral center. Please see the picture and answer this. How many chiral centers are present in this uh, glucose? So if you will find here one chiral center, here one chiral center, here one chiral center, and here one chiral. Total four chiral center. So when chiral center is there, you know na, there is isomer, different isomers will be formed. So there is a formula to count this isomer. Okay, there is a formula. Very good. Four, not five. Puja, not five. Somnath, not two. It is four. Okay, you can see this is one, two, three, four. There is a formula to count this chiral center. That formula is 2 to the power n. Here N is number of isomers. That means 2 to the power 4, that is 16. Total 16 isomers are present in glucose. Okay. Total 16 isomers is present in glucose. Okay. Understood? Total 16 isomers are present in a glucose. Next is DL isomers. Next is D and L isomers. So DL isomers are nothing but they are mirror image of each other. You can see if you see this glucose and if we will keep a mirror, if we will keep a mirror, what you have found. So this and this D-glucose and L-glucose, these are differ from each other due to this mirror. So there is the formula is same. But what is the difference? The difference is the arrangement of this functional group. Here in D-glucose, the hydroxyl group is at right hand side. In L-glucose, it is at left hand side. This is the difference. Okay, so this is called as DL isomers. Okay, understood? Up to this, it is clear. Yes, tell me. Up to this, it is clear or not? Yes, tell me. Up to this, it is clear or not? Very good. Now we will move to the next important part, that is optical activity. So when we heard this optical activity means what? So let me tell you first, briefly explain, then I will come to this next. So optical activity of, so carbohydrates, so optical activity. For that criteria, first and more important criteria is chiral center. The compound which have chiral center, they are called as the optically active compound. The compound which have chiral center, they have optical active. So how you will measure this optical activity? So the thing is a chiral compound, when a chiral compound, chiral compound, when pass through a plane polarized light, pass through a plane polarized light. So what will happen? Either it rotates the lights towards the left, either it rotates towards the left, then we called it as a levorotatory and denoted as small l. If it rotated into right, we called it as a dextrorotatory. We call it as a dextrorotatory. If it rotates the plane polarized light to the left, we call it as a levorotatory. If it rotates to the right, we call it as a dextrorotatory, or we note, or we denoted as. If a racemic mixture compound, racemic mixture means it comes a compound called it a racemic mixture. So it contains 50% D isomer, 50% L isomer. Okay. These are called as racemic mixture. And please remember, racemic mixtures are optically inactive. Okay, they are optically inactive. Note it down, please. If you understood, put a thumbs up in the group. Okay, please show some excitation in the chat box. Okay, I cannot see your excitation. Please show some excitation in your chat box by putting thumbs up. Okay, they are optically inactive. So let's learn about this optical activity of sugar. So optical activity is basically one of the characteristics features of the compound with asymmetric carbon atom. When a beam of polarized light is passed through the solution of an optical isomer, it rotates either towards the right or towards the left. Okay. If the atom is rotated to the right, we call it as a dextrorotatory. If it is rotated to the left, we call it as a liborotatory. So racemic mixture means what? Racemic mixture means if both D and L isomers are present in equal concentration, it is known as racemic mixture or DL mixture. Okay. And racemic mixture does not exhibit optical activity. Very important point. Question can be asked. And dextrose is a dextrorotatory compound. So this is the diagrammatic representation when a unpolarized light passed with a substance. This is containing a chiral compound. These substances are chiral compound. And this chiral compound rotate the plane polarized light to the left or to the right. Then we call it either it is a liborotatory or it is as a dextrorotatory. Now, very important point which we are going to discuss right now is epimer and anomer. Question always asked epimer, anomer, enantiomer, diastereomer. Always question asked. So what is epimer? Yes, Epimer, chiral center and asymmetric carbons are both are same term. Chiral carbon or asymmetric carbon both indicate the same thing. The carbon atom which have four different. So let me complete this. I have few questions to discuss with you guys. Okay, so I will discuss that MCQs and you have to give the answer. Okay. Now, epimer. So when two monosaccharide differ from each other around a configuration around a single specific carbon, then we called it as a what? We called it as a epimer. So there are so glucose. Glucose. So glucose has two epimers. One is your galactose, one is your mannose. Okay. So glucose and galactose are C4 epimer. Glucose and mannose are C2 epimer. Many times this question have asked in exam. Please note it down. Glucose and galactose are C4 epimer. Galactose and mannose are same. So what does it mean? So it is saying that both glucose, galactose and mannose, three have same chemical formula, that is your C6H12O6. So what is the difference? The difference is the position number of C2 and C4. In C2, that is mannose, there will be a difference, and in the C4 for galactose, that is a difference. And glucose, and there is a process. Okay, there is a process called epimerization. So, what is this process? So, epimerization is a process in which one epimer can be converted to another epimer. Okay, so this is a process where one epimer can convert it to another epimer. So what this process called? It the process called epimerization. And what is the one enzyme plays a active role, that is epimerase. So epimerase is the enzyme which plays a active role in the what? This conversion process. This question will be asked. Next is enantiomer and diastereomer. So before uh, showing this or before explaining you this enantiomer and diastereomer, let me draw something. Okay, let me draw something for you. So for suppose, so I am showing my left hand to you guys. Okay, I am showing you left hand to you guys. And it should appear, it will be appear as a right hand in your side, because I am showing here left hand. It will be the person who is standing in front of me. For right hand, it will, for him that or her, it will show as a right hand. Why? Because my left hand is the mirror image of that right hand. Okay, this left hand is mirror image of that. So the question is, when two compound when two compound are mirror image of each other, when two compound or two carbohydrate are mirror image of each other, we call it as what? We call it as a enantiomer. Okay, we call it as a enantiomer. When next is, what is diastereomer? When two compound are not mirror image of each other, we call it as a diastereomer. Okay, diastereomer and enantiomer definition you should remember. So enantiomer are those which having special type of isomer when are mirror image of each other. So two member of D and L isomer. So here we have explained. Okay, D and L glucose we have explained here. So here they are mirror image of each other. So they are enantiomers. They are enantiomers. Okay. Now next is diastereomers. So what is diastereomer? When not mirror image of each other, that is called as diastereomers. Okay, when two compounds are not mirror image of each other, then what we called? We called it as a diastereomer. What we called it as a diastereomer. Now next is mutarotation. So what is this mutarotation? Mutarotation is defined as the change in specific optical rotation during interconversion of alpha and beta form of D-glucose to an equilibrium mixture. So what it is telling that? So during this conversion, okay, during this conversion, during the conversion of alpha to beta form, there is a change in optical rotation. Okay, there is a alpha form of glucose and beta form of glucose. Okay, so during this conversion of, here you can see this is your alpha glucose, it is your beta glucose. So during this conversion of alpha glucose to beta glucose, there is a change in your optical rotation. And due to this change in optical rotation, we call it as the phenomenon that is happened, that is called as mutarotation. So equilibrium mixture contains 63% alpha enantiomer and 36% D anomer of glucose. So in aqueous solution, beta form is predominant due to stable conformation. This is remember. Please remember this beta form is more stable. More stable. In which condition? In aqueous solution. Okay. So beta in aqueous solution, beta form of glucose is stable, more stable as comparison to the alpha. Understood? So I am clearing your each and every point. Okay, I am discussing your each and every point. After this class, you will never have any confusion regarding carbohydrate. I am talking about each and every point in detail. So try to remember all the points. Okay. Next point is tautomerization. So you know what is tautomerism? Have you heard this term about ketoenol tautomerism? Ketoenol tautomerism. Have you heard this term? Have you heard this term ketoenol tautomerism or not? Yes. So what is this ketoenol tautomerism? So, so ketone form, sometime what happens, this ketone form, okay, you can see. So this form can be what happens. So there will be a change of this ketone group. You can see there is a enaldiol form is formed. So this form, this is due to tautomerism. So what is formed during this? The form is enandiols. Enandiols is formed. Okay, when glucose is kept under alkaline condition for several hours, shifting of hydrogen atom from one carbon atom to another, that is called as ketonal tautomerism. When glucose are basically kept under in alkaline condition, it undergo isomerization to form D-fructose and D-mannose. So this is called as tautomerization or enolization. So this reaction known as Lowberry D-Bruin von Encastin reaction. So here result in the transformation of a common intermediate. What is that? Enandiol. So that common intermediate name is enandiol. There are of three sugar. Okay, common enandiol. There is of three sugars. Okay, understood. So for if you want to get important e notes for preparation of your semester exam as well as for the GPAT exam, you can register, you can register, download the GDC classes app, go to the batch section and type the code GDC26. Okay, GDCE26. So that code name again I am repeating. So that code name is in small GDCE26. When you put this code, you will add it to that batch where what you will get, you will get important e notes for B Farm and GPAT examination. Okay, it will help your, it will boost your preparation. Okay, share this information with your friends, your juniors, your seniors, so that they will also get help from this, from all the offer we provide. Now, next important term is reducing sugar and non-reducing sugar. Okay, we will discuss what is reducing sugar and what is non-reducing sugar. So when there is a free aldehyde or ketone group is present, when there is a free aldehyde or ketone group present, we call it as a reducing sugar. When free functional group is not present or free aldehyde or ketone group is not present, we call it as a non-reducing sugar. Next is reducing sugars are either contained in hemiacetal or hemiketal form, but non-reducing sugar only exist in acetal or ketal. First and most important thing, reducing sugar exhibit mutarotation, but non-reducing sugar does not exhibit mutarotation. Reducing sugar forms oxygen with phenyl hydrogen. So what is oxygen formation? We will discuss in your upcoming next classes. Reducing sugar does form oxygen with phenyl hydrogen, but non-reducing sugar does not form. So what is the reason? Due to the presence of hemiacetal and hemiketal form of group. Next is reducing sugar reduces cupric ion of copper to the cuprous ion and with the test, Benedict test, spelling test or Barford test. Or simple, you remember this reducing sugar gives positives towards Benedict test, Felling's test, and Barford test. But non-reducing sugar does not respond to that. So, how to remember this reducing sugar? Simple mnemonic is GF-MLA. GF is MLA. You can remember like this. GF is MLA. Okay, girlfriend is MLA. G for glucose, F for fructose, M for maltose, L for lactose. Please remember. Simple trick, simple trick. So that is GFMLA. Girlfriend is MLA. Glucose, fructose, maltose, and lactose. Okay. Next is non-reducing sugar. There is sucrose, three and starch. Many times question is asked about this fructose, glucose and fructose. So glucose and fructose are reducing sugar, but sucrose is non-reducing sugar. Okay, glucose and fructose are reducing sugar, but the sucrose is non-reducing sugar. Understood? Please tell me whatever points which we have discussed till now, you understood it or not? First, tell me in the chat box. Yes, tell me. All of you guys, please respond. Then I will start discussing about MCQ. 10 minutes we will discuss about few questions. Okay, we will discuss. Understood? Can we start discussing about MCQ? Very good. So let's start. First question. Carbon Carbohydrate have hydrogen oxygen atom ratio. This question was asked in GPAT 2003. So your options are 1.2, 3.1, 1.3, yeah, 2.1. Answer this question. Answer this question. Carbohydrate have hydrogen to oxygen atom ratio. Biswa given the option D. Other students, please respond. Other students, please respond. Please respond. See, there is a trick. Okay, there is a trick. What is the trick? How you will answer this question? You remember the formula. CnH2nOn. The ratio is hydrogen to oxygen. How many hydrogen? Two hydrogen. How many oxygen? One oxygen. So 2 is to 1. Question answer is option D. Okay, 2 is to 1. Very good. Next question. If two monosaccharides, if two monosaccharides are differ from each other around a structure around a single carbon atom, then what is it called as? Epimer, dimer, triose, or trimers? When two monosaccharides differ from each other around a single carbon atom, then what we call? Epimer, dimer, trimer, or triose? Yes, answer this question. Very good. Epimer. When two monosaccharides differ from each other around a single carbon atom, we call it as a epimer. Very good. Next question. Glucose upon treatment with nitric acid, what it will form? Gluconic acid, glucaric acid, glucitol, या hepatonic acid. Glucose on treatment with nitric acid, what it will yield? Gluconic acid, glucaric acid, glucitol, या hepatonic acid. Glucose on treatment with nitric acid, what it will form? Very good. The correct answer is glucaric acid, option B. Option B is the correct answer, glucaric acid. Next question. What are carbohydrates? Please read this question carefully. What are carbohydrates? Your options are polyhydroxyaldehyde or ketone. Empirical formula is CnH2n plus N. Hydrates of carbon. Yeah, all of these. Now answer this question. What are the carbohydrates? Polyhydroxyaldehyde. See, so this is a see. So when glucose react with nitric acid or HNO. So in case of alkali condition, so there will be a form glucaric acid. So it will be discussed under the heading of oxidation and reduction of sugar. So it will be explained in our next class. In our next class, I will explain the detailed chemical thing about how this glucaric acid is formed. Okay, very good. Option D, all of the above is the correct answer. So it has a polyhydroxyaldehyde or ketone. Empirical formula is CnH2n plus N. These are hydrates of carbon. Okay, so that's why all of this is answered. Next question. Which of the function of carbohydrate, which of the following is a function of carbohydrate? It is a dietary sources, provide 4 calorie per gram of energy, precursor for many organic compounds. It involved in cell growth, adhesion and fertilization. Yeah, all of this. Answer this question. Which of the following is the function of carbohydrate? The function. Very good. Option D is the correct answer. All of this. Very good. Very good. Last question of our today's class. Which of the following carbohydrate has a example of triose? Erythrose, glyceraldehyde, dihydroxyacetone, या both A and B? Answer this last question. Very good. Erythrose is a tetrose. It is not a triose, it is a tetrose. Option B and option C both are correct. Option D. So that's all for today. If you have any question, please tell me. First, tell me all of you understood or not. Very good. So the trick is GDT. T for triose. One is glyceraldehyde 3-phosphate. D for dihydroxyacetone. GDT. Okay. So first, tell me you understood or not. Have Have you feel this class is informative or not? First, tell me. The 1 hour discussion, the 1 hour discussion that we have discussed here, did you feel informative or not? First, tell me. Thank you. Thank you so much. So in the next class, we will discuss one another important topic. Okay. So with detailed explanation where we will explain all the things in detail along with the MCQs where you will uh, helps to increase the preparation. Very good. Okay. So thank you. Thank you so much. That's all for today. Thank you. Thank you so much.